In this video, we will focus on solving absolute value equations. The definition of an absolute value equation is an equation really that has an absolute value symbol in it. So let's just remind ourselves what absolute value means in general. So the absolute value of a real number is defined as the distance between that number and 0 on the number line. So x is some real number here, and we take the absolute value of it. That means that x can either be x if x is greater than or equal to 0, or the opposite of x, or negative x, if x is less than 0. So essentially, whatever this value is inside the absolute value, it will always have a positive distance from 0, and only equal to 0 if x itself is 0. So let's take a look at this equation that we have here, the absolute value of x equals 5. Drawing a sketch on a number line is really going to be helpful for absolute value equations and when we look at absolute value inequalities as well. So the values for x that would make this statement true are either negative 5, because negative 5 is 5 units from 0 on the number line, or positive 5, because positive 5 is also 5 units away from 0 on the number line. So we have two solutions here, negative 5 or positive 5. The solution set can be written, I have this kind of shorthand set builder notation, kind of a roster form where you're just listing the values, or you could write that formal set builder notation. All right, so let's generalize what we just talked about. So imagine instead of just having a variable in the absolute value that you have some sort of expression, and that expression is denoted as u here. A is a real number. So if you have an equation, absolute value of some expression u is equal to some real number a, then either the expression is equal to a or the expression is equal to the opposite of a, negative a. So we're going to use this definition to solve equations. So we're going to go through several examples. Each time I'm going to kind of start you off by drawing a picture to get a sense of what the equation means, and then we will solve, and then we will talk about the solution set. So let's take a look at the first equation, absolute value of 2x plus 1 equals 9. So I have that equation written here, and we're going to start by thinking about what this equation means. So my expression is 2x plus 1, so this expression is 9 units away from 0. So let me draw a picture of what that means here. So there are two numbers on the number line that are 9 units away from 0, positive 9 and negative 9. So that means that this expression 2x plus 1 either lives at negative 9 or it lives at positive 9. So that leads me to write two equations. I have either 2x plus 1 equals negative 9 or 2x plus 1 equals positive 9. Those are the two things that can happen that would make this original statement true. So I have two linear equations. I'll solve both of those linear equations using the methods that we've been talking about. For the first one, I'm subtracting 1 on both sides. 2x equals negative 10. Divide by 2. X equals negative 5. For the second equation, subtract 1 on both sides. 2x equals 8. Divide by 2. X equals 4. So I have two solutions, negative 5 and 4. So if I plugged in either one of those, if I plugged in negative 5, went through the order of operations, took the absolute value, I should get 9. If I plug in 4 here, went through the order of operations, took the absolute value, I would also get 9. So let's write our solution set in set builder notation, the set of all x, such that x is a real number, x is equal to negative 5, or x is equal to 4. Either of those solutions would work. Our second example, absolute value of x minus 10 minus 7 equals 6. All right, now in this case, our absolute value is not isolated, so the first thing we're going to do to understand that equation is isolate that absolute value. Move my paper up here. All right, so I want to get that absolute value by itself just so I can understand the equation. So I'll add 7 first to both sides. Absolute value of x minus 10 equals 13. All right, so now I want to get a sense of what this equation is telling me. So I'm going to draw a number line to give me an idea of what's going on. Here's 0. Now I'm looking for a value that will make this expression 13 units away from 0. Now there are two numbers on the number line that are 13 units from 0, and those are positive 13 and negative 13. So that means that this expression, x minus 10, is either equal to negative 13 or equal to positive 13. So those are the two equations that I'll set up. X minus 10 equals negative 13, or x minus 10 equals positive 13. So if each of those expressions are 13 units away from 0, I want to find the values of x that make that happen. So I'll go ahead and solve each of these equations. Add 10 on both sides here, and I have x is equal to negative 3. On the other side, I add 10 to both sides. I have x is equal to 23. So there are two values of x that would make the expression x minus 10 13 units from 0. And those two values are negative 3 or 23. So x equals negative 3 or x equals 23. It's going off my page there. All right, so again, I have two values of x that make that original equation true, and you can check each one of them, and each of them should work. All right, finally, the third example, I'll fit on this page here. Again, our absolute value is not isolated, so we'll go ahead and isolate the absolute value first. There are some rules and properties of absolute value that might allow you to multiply in and outside of the absolute value, but to avoid having to learn those rules, we could just isolate the absolute value. This negative 3 is multiplying. I can divide both sides by negative 3 to undo that multiplication. Negative 3 divided by negative 3 is positive 1. So that just leaves me with the absolute value of 8 plus x equals positive 12. All right, so once you have your absolute value isolated, you could use the number line to help you set up. So I'm looking at the expression should be 12 units away from 0. So 8 plus x is either equal to negative 12 or 8 plus x is equal to positive 12. So let me set up my two equations. 8 plus x equals negative 12 or 8 plus x equals positive 12. I'll solve each of those for x. Subtract 8 on both sides. Here I have x equals negative 20. And then on the other side, subtract 8. And I have x equals 4. So the two values for x that would make the absolute value equal to 12 or 12 units away from 0 would be either negative 20 or 4. So the set of all x such that x is a real number, x equals negative 20, or x equals 4. All right, so again, notice each time when we're solving absolute value equations, we're going to isolate the absolute value first and then set up two equations. So you may have noticed that the two equations that we set up take the constant and just negate the constant and then rewrite the constant. It was the same thing that we saw in the last example. After we isolated the absolute value, we then rewrote two equations where we negate the constant and then keep the constant. If you ever get confused, you could always go to the graph to help you set up your equations. In the next video, we'll go through the remaining examples that you see on this slide.